Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X, Shifting and Weakening Earth's Magnetic Field. Now, Andy Chang, a retired seismologist living in Taiwan, found that the sun's position according to his compass on October 7, 2018, at sunrise had changed by 8 degrees. A tower which he knew was directly south of his house also shifted its position by 8 degrees according to the compass. So it was not that the sun was rising in the wrong position, but that everything, including the sun, seemed to have shifted according to his compass reading by 8 degrees. He knew that the sun had risen in the correct position on September 22nd, which was the autumn equinox, when the sun rises exactly in the east, or at 90 degrees east of north. And so after the autumn equinox, the sun is supposed to move southwards, reaching a sunrise position of 115 degrees east of north. And he's, of course, living in Taiwan in the northern hemisphere. And this is illustrated here, how during the equinox, the spring and the autumn equinox, the sun rises exactly east and follows this line. So it moves southwards for anybody living in the northern hemisphere, south like that, and then sets exactly in the west. But as we move towards the winter solstice, and that's what we're supposed to be moving towards between September 22nd and October 7th, the sun rises a little bit more to the south, until on the winter solstice it will rise over here, which would be 115 degrees east of north. So this would be the bearing from there to there, and the angle then would be 115 degrees. And when it's the equinox, September 22nd, then what we have is an angle. So it rises on a bearing which is exactly 90 degrees. We have a 90-degree angle from the north line. So after September 22nd, the sun's supposed to rise more towards the south. So it's supposed to rise at an angle greater than 90 degrees. But according to him, instead of moving that way, it actually moved this way. So it was at 82 degrees, so a bearing like that, less than 90 degrees. So it moved back towards its summer position rather than moving towards the winter position. That's in the opposite direction. So this meant that the sun had moved in the opposite direction that it is supposed to move in at this time of the year. But Andy Chang checked to see if the Earth's rotational axis had also shifted by checking that an antenna on the ground tuned to receive signals from a satellite in geostationary orbit had not developed reception problems. There had not been any TV signal reception problems between September 22nd and October 7th, when the shift must have occurred, or within that time. So the Earth's rotational axis had not shifted, only the magnetic axis had, by at least 8 degrees. Andy Chang also remembered a 1983 paper by a seismologist friend of his, who had found that the Earth's rotational axis swayed backwards and forwards after a major earthquake. There was a major earthquake of 7.5 magnitude in Indonesia on September 28, 2018, and thus in the time frame when the magnetic axis shift occurred. But since the rotational axis had not shifted, that could not have been the reason. And here's an antenna designed to receive radio signals from a satellite. It's actually a dish like that, and it's meant to focus the signal that falls wherever it falls on the dish, focus it onto this point. So that would be the focal point for the dish. Now, if the dish is not correctly aligned with the satellite, then it will not be able to focus the signal onto this reception point, and so the signal would be lost. So if the Earth's rotational axis shifts, then the antenna would not be in the correct alignment, in the correct position, and the signal will be lost. But no signal loss occurred. So what could have caused the Earth's magnetic axis to have shifted by as much as 8 degrees? This is an indication of a severe magnetic disturbance. Andy Chang did not report on whether the sun's sunrise position eventually reverted back to its normal position, which would indicate that the magnetic disturbance was temporary. However, we also know that the likely cause of the disturbance was most likely the arrival of a Planet X system stellar core. These objects are now filling the solar system. They come in as comets and either remain with the sun and in the solar system for good, or remain for an extended period of time and then move on, following an elongated orbit around the sun, which will see them come back into the sun's corona after a certain period of time. And for more details, you may look at Article 373 entitled Planet X System Orbits. Now, Planet X system stellar cores are energy-depleted celestial objects which have as a result a low gravitational influence, but they seem to retain a strong magnetic field in their old age and will thus influence the Earth's magnetic field. You may look at Article 316 entitled Rogue Planet with a magnetic field 200 times stronger than Jupiter's. However, since the Earth's magnetic and rotational axes seem to be in a fixed position with respect to each other, it is likely that a large object approaching Earth and causing a magnetic axis shift will also cause the rotational axis to shift. So it is not likely that the Earth's north or south magnetic poles were repelled by a high magnetic field object approaching the Earth. However, although the Earth has a permanent magnetic field which originates in its solid core and solid part of the crust, most of the Earth's magnetic field arises from the motion of charged particles in its outer layers, and thus a large disturbance to the flow of these charged particles can shift the overall magnetic field of the Earth. And you may look at Article 167 entitled Magnetic Pole Shift and Crustal Displacement. It is likely that the Earth will be able to re-establish equilibrium once the object moves away from the Earth and thus stops withdrawing material from the Earth's ionosphere, as the charged particles will redistribute and realign themselves with the Earth's permanent magnetic field. And this is an illustration of how the Earth's permanent magnetic field comes about. It has two components. The first component comes from the core itself, which has charged particles in it with their magnetic moments aligned. Specifically, it's got large amounts of iron, so that it creates a permanent magnetic field in a certain orientation, and that's represented by the gray arrow. Then the purple arrow represents the magnetic field from the solid part of the mantle and the crust, which also has a permanent magnetic field, and it will have a certain overall orientation. Then the sum of these two orientations gives rise to the Earth's magnetic field, and this will then establish the magnetic axis of the Earth. The North Pole would be here, the South Pole would be there. The rotational axis seems to be at a fixed orientation with respect to the magnetic axis. So if this one shifts, the other will shift as well. Then there's the external part of the Earth's magnetic field, which is actually stronger than the permanent part, but it's aligned to it. And it's created by particles from the solar wind as well as charged particles belonging to the Earth, which interact with Earth's permanent magnetic field so that a stream of electrons flows westerly. So this is the electron ionospheric stream. along the equator, and streams of positive ions flow easterly at lower and higher latitudes. These currents influence the Earth's major air currents, the jet streams in the atmosphere below the ionosphere. The ionospheric currents produce a non-permanent portion of the Earth's magnetic field, but it will be aligned with the Earth's permanent magnetic field, as I said. However, a sudden disruption of the current can affect the Earth's overall magnetic field orientation. Now, stellar cores have most likely for some time been drawing the Earth's atmosphere, and in particular its ionosphere, and have thus been depleting the Earth's ionosphere and creating ionospheric holes, just like they have depleted the Sun's atmosphere or corona and created coronal holes. And you may look at Article 403 entitled Earth losing atmosphere due to Planet X related gravitational diffraction, and Article 406 entitled Planet X effects on the Earth ionospheric holes. With the loss of charged particles, which make a huge contribution to the Earth's overall magnetic field, this field would decline in strength over time, and in addition, the periodical loss, large losses, as a stellar core arrives and makes contact and withdraws large amounts of material, may lead to a sudden shift in the Earth's magnetic field. And this seems to have occurred between September 22nd and October 7th. So in conclusion, the Earth's magnetic axis shifted by at least 8 degrees between September 22nd and October 7th, 2018. This was most likely due to the Planet X system effect on the Earth's magnetic field, as the objects withdraw atmosphere and ionosphere, thus creating ionospheric holes, which will then affect the Earth's magnetic field. Over time, this will lead to a weakening of the Earth's magnetic field, in addition to sudden shifts as an object arrives and withdraws material from the Earth's atmosphere. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.